What do we remember about exponents? The nice thing is that we are revisiting exponential stuff right now. So this is a little bit on our minds, but not this stuff. It's been a little while since we've done questions like this. So this is some stuff that we're going to review, but some of the stuff we review today will actually help for the test tomorrow. So we have to simplify and express each answer with positive exponents only. Some of this is BEDMAS. So this is a bracket. There we go. A bracket times another bracket, but this second bracket has an exponent on it, and BEDMAS says we do exponents first, so that's what we have to do first. So I'm just going to rewrite out this bracket. And the exponent in this case, it's kind of like distributive property. It applies to everything. Put your pencil down for a second and watch. I want to show you something, because when this is a common mistake that people make all the time. And this is where some people find math to be frustrating, because there are subtleties to some of the rules, and some people say the rules change, and they don't, but it can come across that way sometimes. For a question like this, we do not just do x squared and 6 squared, right? We don't do that. This is actually x plus 6 times x plus 6, not 2. And you end up doing the whole expanding thing, and you end up with 3 terms, not just x squared and 6 squared. But in this case, that is what you're doing. This is 6 squared, x squared, and y squared. I am just squaring everything inside. And the reason is because it's multiplying. So if you wanted to, don't write this down. I think we'll skip this step. But it is technically 6xy times 6xy, because it's the whole thing squared, which means you get 6 times 6, x times x, and y times y, because that's how you do that multiplication. So it ends up being 6 squared, which is 36, x squared, y squared. And then we do the same thing, and when we're multiplying, these are monomials, because there's no adding or subtracting. So I just multiply the parts that go together. I just multiply them together. So the 3 times the 36, use my calculator for that. I believe it works out to 108. X to the 4 times x squared. How do you do that? Very good. Add the exponents, right, is what we mean. So that's 4 plus 2, which is 6. So it's x to the 6. And this one's tricky. Again, you can use your calculator. Y to the negative 3 times y squared. Negative 3 plus 2 is negative 1. Use your calculator if the integer math is messing you up. Sometimes you're good at stuff, but then it's an exam and you're a bit nervous and it's harder to think, and you're more likely to make small, silly mistakes. So just use your calculator for those computations when you need to. The instruction said no negative exponents, positive exponents only. So the positive exponent, or the negative exponent, is only on the y. This was another common mistake. Don't write this down. People did this 1 over the whole thing. So you're right, a negative exponent does a 1 over. But the negative exponent is just on the y. And you've got that one and you've got that one, right? So what should this actually look like? The 108 stays on top. The x to the 6 stays on top. And the y just goes to the bottom. Y to the 1, which is just y. Next one, same idea. No extra exponent in this one, so we can start dividing right away. 15 divided by negative 3, so that's negative 5. These ones are nice because it lines up the parts that are supposed to go together, right? So I do the coefficients with each other, the x parts with each other, and the y parts with each other. So this is x to the 2 minus 5, which is negative 3, and y to the 6 minus 5, which is y to the 1. And then we do the same thing here, where just the x part goes to the bottom, but And now it's got a positive 3 exponent. Oops. Questions about that? Now we have 2 that are quite a bit more difficult. And if you can do these, you can do anything. It's good to review. It's good practice. I wouldn't focus on these kinds of questions often on the exam. We don't ask the hardest questions. The whole exam might have 1 or 2 more challenging questions. My focus would be on those first 2 questions are a little bit more straightforward. These ones, there's just so much to think about all at once. It's easy to make some simple mistake. But anyway, it's good practice. So I'm going to do the top first, get that fully simplified, and then the bottom. What we can do at the same time on the bottom is we can manage that exponent that's out there. If you think you can do that, like do the multiplication on top and the exponent on the bottom, go ahead and start. Give it a try. If you want to do it along with me, -8 times -9, it's going to be positive. So this is x to the -4 times x to the -3. So it's -4 plus -3. Should be -7. And if you're doing this, if you're already started, make sure you check as you go that you're doing it right. And then y to the -2 times y to the 4 is -2 plus 4, which is y squared. All right. 6 squared again, 36. And -1 times 2, because when you do a power of a power, you multiply the exponent, so that works out to -2. And then that works out to y squared. And this is where you could start to do these in different ways, but I think the best thing to do here is now do the division and handle negative exponents at the very end. (72 divided by 36) works out to 2. -7, so I'm subtracting exponents. So this is like, you can write it off the side, -7 minus -2, which is -7 plus 2. So this should be x to the -5. And y squared divided by y squared is 1. So there's a 1 here, but we don't have to write it. And then I got to deal with the negative exponent, and I get 2 over x to the 5.
I did 2y over 5x. Is that just because the 2, subtract the 2
is 0, and y to the 0 is 1. So it's not y to the 1, it's 1. So the y shouldn't be there. Yeah, be careful of that. All right, and the last one of these. And again, this one's like, what do you do first? I could see some people starting with the wrong step and end up confusing themselves. But it's not super clear or obvious or intuitive how you would start this. I think the first thing you do is you just manage the negative. So what does a negative exponent do?
change the signs. Oh, sorry, I'll flip it.
It'll flip it. Flip the top and the bottom. So I'm just going to do that whole thing. 12m squared, but not change anything. The other negative signs, this was another common mistake. People change that to a positive, but I haven't done anything with that exponent. I only flipped it because, whoops, it's not negative anymore. I only flipped it because of the negative outside. So that became positive. This negative became positive, but everything inside stayed the same, just flipped. Now you can either do the division, then multiply by 2, or then manage the exponent on the outside, this big 2. Or you could do this 2 to everything inside. Let's do the inside first. 12 divided by 6 is 2. M squared minus negative 3 is plus 3, so that's m to the 5. N to the 7 divided by n to the 4. 7 minus 4 is 3. So now this is 2 squared, which is 4. M to the 5 all squared. So that's 5 times 2. And n cubed all squared, that's 3 times 2. There we have it. So every question is just a little bit different where you do things in a kind of a different order, and that is part of the hard part of this. But all right, review of rewriting things in radical form. A question like this, if it came up on the exam, you could do it all in one step, for sure. But we're going to do it in 2 steps just to highlight the different parts. What does a negative exponent do? Flips. So this is 1 over 5 all to the 1/4. Positive 1/4 now. And what is an exponent that's a fraction? What does that do? So this is something that's important to review because it's actually something that you were very good at back when we started this way back in September, but we haven't used it since, so I wouldn't be surprised if people have forgotten, just need a quick refresher. Remember, it does this. So, and when I have an exponent on a fraction, now because it's a 1, it wouldn't make a difference, so you could cheat and skip that. But if it was any other number, a 2 or a 3, you'd have to do this. So I'm going to show it anyway. So remember, this is the same as writing. This is what radical form means. With the square root. And it means the 4th root of 5. And if you plug that into your calculator, it is not going to give you this answer. It's going to give you some nasty decimal. So I'm going to actually evaluate the top because you can. Normally, this is how we would write this solution, is like this, just 1 over. But if you left it like that, that'd be fine. But if you plug that into your calculator, 5 to the negative 1/4 or 5 to the 1/4, it's going to give you a decimal. And if you write that down, that's not going to be worth any marks because the instruction specifically said write in radical form. Is that familiar now? You remember doing this? A little bit at least? Okay, let's try the next one. So this time the base is negative, the exponent's positive, but it's 5 over 4. This is written to save space on the page, but it means that, right? Or sorry, 5 over 4, 4 over 5. So we know that the denominator of the fraction goes there. The negative sign has to be inside. It's the whole root. And then it's the whole thing to the exponent 4 is how you would do that. So the 5 goes in here in the radical sign and the 4 goes out there. Now this is like 3 and x to the negative 1 over 3. So that exponent is not on the 3. If it was going to be on the 3 as well, you'd have to have brackets around it like that. So the negative sign is going to flip the x to the bottom, but the 3 is going to stay on top. And then we rewrite that in radical form like we're supposed to. Again, you would not have to show both those steps. This would be, you could go straight to the answer for a question like that. Okay, and then the other kind of question we did similar to this is if it gives it to you in radical form and you have to write it in exponential form. Go ahead and try. You should be able to do that. This is 6 squared, so that means the 2 goes on top, right? And we know where that 5 goes, hopefully, since we just talked about it. So it should look like that. 6 to the 2 over 5. What is this? What does that mean right there? Because there's no number, so what does that mean? Yeah, it's a square root, which means it's a 2 there. That's what you used to do all the way back in probably elementary school or grade 9. So there's a little invisible 2 there. When there's no number, it means the square root, which is a 2. So this should be x to the 5 over 2. Okay, and this last one, the base is negative, but this whole thing is also in the denominator. So we're going to, the instructions don't say this, but if it said, I don't know how you would actually word that, but it doesn't matter. We're going to write it in the full way. In fact, let's do it in 2 steps. So this is going to be 1 over negative 4 to the 1/5. But if I wanted to bring that up so that it's not a fraction, it'd be negative 4 to the negative 1/5. And what's the point of all this? I mean, it's hard to see. It's hard for us to really see, but there might be a reason why you don't want it written as a fraction. You want it written like this. When we write it in exponential form, we can do more things with it, simplify in different ways, that kind of thing. So there are definitely procedures in math or places that you could find yourself in math if you kept taking higher math, or if you took math even in college or something, where it would make it easier to rewrite it like this. So it is a useful skill. Unfortunately, we don't get to a point where we really get to see it in action. Any questions about that? We got a few more different kinds of questions to do. Okay? So we're going to evaluate, leave your answers as a fraction where necessary. That means no decimals. Again, that means you can't just punch it into your calculator. You should also show your work, because some of you might have calculators that will give you fraction answers, but usually the idea behind these kinds of questions is that you're showing that you're using exponent laws to simplify and evaluate, not just punching into your calculator. All right, so I hope you're ready to go. 2 to the negative 3. I'm going to manage the negative exponent first, which makes it 1 over 2 to the positive 3. And 2 to the positive 3, what's that? Don't say 6. Good. So the answer is 1 over 8. If we were going to do this one in a lot of steps, I would probably handle the negative first. What does 25 to the 1/2 mean? That's what we were just talking about. It means the square root of 25. But you could definitely go straight to that step if you were doing this on a test. And the square root of 25 is 5, so the answer is 1 over 5. I changed this one. I meant to change this one, but it looks like I didn't actually change the whole thing on here. So I'm going to change this to, I'm just going to scratch it out, to -2/3. So 64/27 to the -2/3. So again, the first thing we probably want to do is manage that negative, so it's going to flip it. (2/3) means cube root and then squared. So, and I'm going to do that on the top and the bottom. So it's a cube root of 27 all squared over the cube root of 64 all squared. And then doing that on your calculator, the cube root of 27, you probably, remember you all found that button on your calculator. You got to know where it is. And so you punch that in, because a lot of the cube roots you probably don't know. You might know some of them. You might be able to figure out some of them, but most of them we probably don't know. So the cube root of 27 is 3, so this is 3 squared. And of 64, it's 4/4 squared, which is 9/16. Okay, last group of questions for today. Now this one's awesome because this is perfect review for the test for tomorrow, because this kind of stuff is on there again tomorrow. Solve for x. And this one's kind of already done for us, because the trick behind these, if you remember, is the bases have to be the same, but the base on the left is 4 and the base on the right is 4, so they are the same. So this is the step where we use the therefore symbol, and we say 3x equals x minus 1. If the bases are the same and there's no other junk, the exponents have to be the same. And then I just solve. So I'm going to move the x over by subtracting x on both sides. I get 2x is -1, and divide both sides by 2. X is -1/2. And a left side, right side check was something we did for those as well, if you recall. What's different about B? The bases are different. So we have to figure out some number that I can change them both into. And this can be tricky if you don't know your times tables very well. But what can I, like, what is 9 a power of? 3. So probably 27 will work that way as well. So you could just guess and check and try. Okay? And 9 is 3 squared. So this is 3 squared all to the x minus 4. And 27, we kind of already saw this, is 3 cubed. And I would write this, the next step would be writing it like this, because I multiply the exponents here. So you have to know that that's how that works out. And now I can go, therefore, 2 times x minus 4 equals 3. And we have a simple equation here to solve. I'm going to do the brackets first. Add 8 to both sides, so then 2x equals 11, and x is 11/2. Okay, the last one's a little bit trickier because it's got a big number, 81, but again, we know 27 is 3 cubed, so it turns out 81 works out that way as well. It can be turned into a 3 to the something. So I'm going to kind of skip a step here just because why not, right? So I'm going to write it this way instead. We know this is 3 cubed, so it's 3 to the 3 times 3x minus 4. Like we know it's going to work out that way anyway, so I'm fine if you want to jump to this step. And 81 is 3 to the what? Anybody want to guess? Like, it's not 3 because that's 27 to the 3. So it's 4. Just try the next number. These get big really fast. So unless it's like in the 10,000s, it's not going to be a big number. So this is 3 to the 4 times x minus 1. Therefore, 3 times 3x minus 4. Okay, and I got to multiply all of this out. So distributive property on the left, 9x minus 12. Distributive property on the right is 4x minus 4. I'm going to move the 4x over to the left by subtracting 4x. And I'm going to move the 12 to the right by adding 12. So negative 4 plus 12 is positive 8. I went over that quick. So like I said, if you have questions, you can stop me and ask. But I think by now, you don't need me to walk you through most of those little steps. You're probably pretty confident of that. But if you have questions about it, by all means, ask. So we're going to stop there. That's Unit 1. On Friday, we're probably going to try as much as we can to get through a couple units. So it'll take a bit more time, but you still have half the period to do some review, whether it's for the test or for the exam, whatever you want to do.